Hey guys, this is SyedaZaidi, and today I'm going to be talking about 10.3 in pre-calculus, and this topic in 10.3 is called ellipses. Now, ellipses is, it has actually a graph kind of shape, and in the graph, or on the graph, it's like a white circle. If you want to search more about it, you can search it up, on anywhere, to be honest. So basically, this ellipses part, it has many characteristics. It involves like the foci, the vertices. You will learn more about foci in a little bit. A lot of formulas on how to solve or how to find out the standard form of the graph, or finding the standard form, or trying to find like basically all those things and characteristics about. We are going to be talking about those in when we are solving problems together. So let me just show you like a review of what you're going to be expecting, or what you should know before starting or solving problems of ellipses. So basically, ellipses is is a set of all points x and y in a plane, the sum of whose distances from two distant fixed points called foci is constant. So basically, on the graph, the foci is constant, and it's not like inconsistent. It's not inconsistent, it's constant. Okay. Basically so basically on the graph, the foci would be like in like 2 points, for example, or it could be like 1.2, 1 point also. But most of the time it's mostly 2 points, and on the graph for the ellipses, because it could be like over here and over here. I don't know how to explain it to you guys, but if you do search it up, you will see what I'm talking about foci on the graph. So the formulas you should really know about is all of them, to be honest, because these are the familiar formulas that you will need to know and get used to when you're solving ellipses. Now, the first formula you should know about is b squared equals to a squared minus c squared. Now, this is honestly like the Pythagorean theorem, but it's only different because it's kind of different because you're just trying to find out. You're just trying to subtract. You're not like multiplying or finding square root of anything. You're just gonna like substitute like the terms or the numbers in the alphabet, and then you're gonna just or subtract, and that's all. And so this is how the formula uses by. But you will see more when I actually do the problems, and you will see how I interpret all these numbers in the formula, and you will see how I solve it. So now the other formula I need to talk about is now the horizontal and the vertical main points, or main axis. So these are actually really important in the ellipses part, because these are the formulas or the things that make you find specific things off the graph. It gives you like an answer or like a standard form of how it would look like on a graph, and or the ellipses standard form equation that you will find on the graph. And yeah, pretty much. So x minus h squared. So the only difference between these two formulas is that the denominator is actually opposite, but the numerator is actually the same. So there's nothing different on the numerator, just the denominator is actually reversed in both of them. So example, like over here is a squared over b squared, but over here is b squared plus a squared because of the vertical and horizontal differences. But yes, this is basically what it looks like when it's horizontal and vertical in the main axis. The other last formula I want to talk about is the horizontal and the vertical main axis also, but this is like a different type of formula that you will be using in order to like interpret all the numbers, and basically trying to find the also like the other standard form too, or the equation of the graph. So this one is x squared over a squared equals to y squared over b squared, and this is mostly like a cross kind of formula. You know what I mean? Like it's like example finding x on a two base fractions. Over here it's more complicated and more complex on how to find it, but you mostly just have to, it's like the same kind of formula, I guess you could say, but a little different, if you know what I mean. But you will see more, like, I will show you guys problems of this. I will definitely show you problems of the differences between them, just in case, so you know how to actually know the meaning of the formulas. And this is actually horizontal, so it's actually equal to 1. Now listen, both of these formulas are equal to 1 only. It's not equal to 2 or 3 or any other number. It's only equal to 1. Just remember that. Just don't make a mistake on making it equal to 2, because that would be definitely wrong for the whole equation. And so it's always equal to 1. Just know that. The x squared. So basically the same thing, the same problem, the same way, just like the same. Okay, so basically the two formulas I was talking about before, the complex ones, has the same issue as the first one. So the first one is the opposite of the denominator is opposite, but the numerator is the same. It's reversed in both of them. So example, horizontal be a squared equal to b squared, and here for vertical be equal to b squared equal to a squared. Now over here it's the same because horizontal is a squared b squared, same with here. Okay, you see how it's kind of similarity right there. So basically these are the main formulas that you will need to know about when you get to the problems or ellipses. And yeah, so let's get started with the problems. Okay, so this is the first problem of this topic, and this problem consists of vertices and the foci. So basically we're going to interpret these numbers into a formula that we can find to make it a standard kind of form of the equation to find the ellipse. So now these two things are the only given characteristics we have in order to find the others. So these are the only answers we have, but we're going to try finding the other characteristics also. So let's see what we can have here. Let's try finding the center. The center is always h and k, okay? The center formula is always h and k. It's kind of like x and y, I guess you could say. But for the center, it's actually 0 because there's nothing really between the vertices and the foci. It doesn't really think there's no other number in sub-0 and 0. The other part we're going to talk about is, well, let's see what vertices. Okay, so vertices will be equal to a, and the foci will be equal to c. So let's do vertices of the vertices is equal to 0 and plus and negative 8, which is equal basically to a equals to 8. And the foci, oh, sorry about that. The foci is basically 0 and plus and negative 4. Why did I put a T right here? That's not what I meant. So basically, that means foci is actually a symbol of C, so C equals to 4. Now, they're both positive, so let's just stick with positive in this problem. Now, remember how previously I talked about how there's a formula that you're going to be subtracting. It's kind of like the Pythagorean theorem, but not really, because you're not really finding the multiplication, or you're not really multiplying or dividing anything or finding the square root. It's just subtraction. That's all. So basically, the formula I was talking about right now, is b squared equals to a squared minus c squared. Now, in this formula, you see how we found a and c? Now, we're trying to find b squared. So that's why we have the formula b squared to a squared minus c squared, because the only characteristic we can find in this formula, or in this graph, is only a and c. That's why we have to find the b squared part in order to complete the characteristics, or to find the standard form. So now let's see how we can substitute this. Now, since we're trying to find b squared, that means that there's nothing to substitute for b squared. That means we have to substitute a squared and c squared. Now, okay, let's see. So now, since it's a squared, that means we have to times it by 2 times. So 8 times 8 is 64. So it'd be 64 minus 4 times 4 is 16. So 16 equal to 48. So that means that b squared is equal to 48. Okay? Now, the last step is just substituting the whole formula. Okay? Now, the formula we were talking about recently was finding the standard formula, right? And it was x squared over b squared plus y squared over a squared. Now, this formula is actually vertical. Now, so this is a vertical formula, or this is the major axis of a vertical, or yeah, vertical axis. And so let's try substituting it. Now x squared and y squared is going to stay the same, and the 1 is going to stay the same. But b squared and a squared is going to be different because we have characteristics. We already have the terms. We already have the answers for those terms. So x squared just stays the same. Okay. So let me just make it as that. Now the denominator is going to be different because the only thing we have to substitute in this formula is just b squared and a squared only. Don't substitute the y, x, and y because x and y stays the same. It does not do anything. Okay, it just stays with the formula. So b squared we found out was 48. So 48, and a squared we found out was 64. So that means that the standard form of this characteristics, or the standard form of this ellipse, is x squared over 48 plus y squared over 64 equal to 1. Alright, so this problem is more like a graph kind of question. So it says that find the standard form of the graph. So we're going to have to find the graph and try finding standard form from the graph. Like we're going to try finding all the characteristics from the graph in order to interpret with the formula, or the formula to find the standard form. Now in this problem, the only thing we could do is find the points first. So the first step we're going to try is finding the points. Now this one, okay, so if you didn't know, ellipses are actually shaped like this, like a white circle on a graph, okay? This is an ellipse, by the way. So now the first part we're going to do is, so basically first, just jot down all the points on the graph, okay? So we have 2, 0. We have here, which is this part, it is 0 and -1. Here it's 2 and -2. And right here, this part right here, is 4 and -1. Still 2. Okay, it's a little squished up right now, but you can kind of see what I mean by that. So now the vertices we saw right here is, well, 0, -1 and 4, -1. Now vertices are always sideways. It's always left and right, not here. This is not left and right. This part is left and right, which is basically the vertices, okay? So let's try finding the vertices. So for the vertices we found was, the vertices is, which is the first characteristic we found on this graph is, well, 0 and -1, and we found 4 and -1. Remember, x and y, okay? X and y. So okay, let's see here. So vertices is always a, okay? So that means that a would equal, okay, hold on. Let me just try finding this first. So now we're going to try finding the, let's see, what we can find from the graph. So in this graph, we can find the center point, which is h and k. So the center point, it looks like, the center point is always like in the middle. It doesn't show on the graph, but when you do find the center point in this, basically the center point is basically the middle of the circle, right? Because center is basically equal to middle, right? So center point of the circle would be here. So that means it's 2 and -1. It's kind of messy on the graph, but you can see that this is a 2, because 1, 2, 3, 4, and then like -1 would be right here. So that means that this is 2 and -1 as the center point. So this is the second characteristic we found. So center is 2 and -1. So just remember, guys, it's h and k, okay? Same thing, center is always h and k. Now the endpoints of the minor axis we have right here. Now the endpoints are 2, 0, 2 and 0, and 2 and -2. You can kind of see the common sense because endpoints, you know, of the minor axis. So let's say endpoints, I guess. Endpoints is 2, 0, 2, 0, and 2 and -2. Okay? Now we're just going to find out the a. Okay, so the a part would be actually 2 in this problem because it would be 2 because of the 4. So that means that a is equal to 2 because of the 4, and okay. Basically when you solve these two vertices together, you will get a 2. okay? So the second step is finding the b part. So b in this problem, because the thing is that so basically we're trying to find the horizontal axis here, because we already have the vertices, we already center, we already have the endpoint, but we can't find the horizontal axis because in this graph it doesn't show. So we're trying to find the horizontal kind of axis and basically finding the standard form. So in this kind of topic, or in this case, we're going to try finding b. So here we have 0, -2, 2, and 2. Okay, so when you try solving them together, you'll get at least, I'm pretty sure we get a b equal to 1. So we have a equals 2, b equals to 1. Okay? So I think now we can solve it, actually. Yeah. Alright, now the thing is that you don't have to find c, because c is not really a form in the graph. It doesn't really participate, so you don't really need it. Honestly, you really don't need it at all. Sometimes in the problem you will already find c because it already gives you a c, but normally when you don't have c, you don't have to solve it for c. You can just solve it for a and b only, because a and b are the only thing that matters on the standard formula. So the standard form for this formula, because since we're trying to find the standard form of the graph, because we have the graph first, right? We're gonna try using the complex one that I was talking about, the one that has more. Instead of like x squared over b squared or something, it'll be more like x minus 2 squared over like b squared, or a squared actually, but then, since horizontal will be x minus h squared over a squared. So previously I talked about that in the review part. So here we're going to try doing, so this is the formula of the standard form we're going to be using since we're interpreting from the graph. So this is the formula we're going to be using because we're trying to find horizontal, right? So it will basically be equal to, okay, so x, remember, the numerator is actually, okay, so the numerator is actually does count on this graph, on this formula, because we have the numerator and the denominator substitutions, because we found the center here. We found the center, which is, so basically the center we have is 2 and -1. So that's why we're gonna have to substitute the center, the 2 and -1, on the formula. And basically we're gonna be substituting everything except the x and y. We only have to substitute h and k. So it'll be x minus 2, because remember, it's minus, because listen, when you do x equal to 2, x plus 2 equals 0, it'd be minus 2. And if you do x minus 1 equals to 0, it'd be x equal to 1. So you see how it goes like that? So just remember doing that before. Don't just copy the center. You have to find the zeros first. You try finding y equal to by 0, okay? Always do that before you try substituting the formula. So now a squared is equal to what? Now remember when we found a squared, so we found 2 as the a squared, right? But the thing is that we're gonna normally have to go by 4, because 4 is basically what equals to 2, right? So it'll be 4 here, and then plus y plus 1, remember, because x equal to 1, y plus 1, oh, and also it's squared, by the way, so don't forget that. It's always squared, don't forget the squaring. And then it will be equal to 1 as the b squared, because we found 1 right here. Okay, so this is what you will get for this formula. Also, actually, if you think about it, it is 4 because of a squared. So let me make it more easier for you guys to make more sense, because I think I was being a little too confusing at first. So you see how a squared, because these are squared, right? So 2 squared will equal to 4, and then 1 squared will equal to obviously 1, because 1 times 1 is 1. So this is what it would look like in this graph. Okay, so now this one is a little more It's like the opposite of what we were doing before. So in this part, this is the third problem, and this one is actually, it gave us actually the standard form of an ellipse, and then now we have to find the center, the vertices, and the eccentricity. So it's kind of a little more like an opposite reverse of what we were doing before, because last time we were trying to find the characteristic first and then interpreting all those characteristics in the formula. But in this topic, or in this sense, we're trying to do the opposite now. We're trying to find the characteristics from the standard form. So it's a little funny to me because it's the opposite way. Okay, so now in this part we're gonna try. Okay, so the first step what to do is try making the formula more easier as you can, or try like simplifying it, I guess you could say, so that's more easier for you when you try solving it. So because if you solve it by this, it's gonna be a little more complex for you, so don't make it hard for yourself. Okay, just try simplifying. Okay, so because if you think about it, this as actually like, it's mostly we're actually not sure. I'm not actually sure if it's b squared a squared, but in this case it's always b squared, right? It's always b squared a squared. That's why it's like squared, so it'd be 5 and 4 as, you know, the before part, because when you're trying to interpret all the numbers in the formula, you will have like x over 5 and then plus y over 6, or sorry, y over 4. And then when you try like squaring it, because in the original formula it's always a squared, right? A squared plus b squared in the formula, so that's why it has a bigger number than usual. So it will be ax over 5 squared plus y squared over 4 equal to 1. So this is how it looked like in the original formula, but we made it more complex because you have to substitute it, right? So now this is basically the ellipse, okay? So now let's try identifying A and B. So A is 5, so that means this is a horizontal kind of this looks like a horizontal axis. Horizontal main axis, let's say that main axis, okay? So that means that the A is equal to 5 and B is equal to 4. Okay, we found two things, okay. Now C, we just have to, if you want to find C, you would have to do A plus B form. So if you think about it, okay, so A plus B, now A plus 5 plus 4 is 9, so that means that would be 9 equal to 3. Okay, so we found C, which is 3. So the center we have here is, well, 0, because we don't really have anything for the center, right? It doesn't really simplify anything for center, or doesn't really mention anything for center. Vertices, well, let's see. Now the vertices would make sense because the vertices is always a and k. It's always h plus a negative a and k, right? As a formula. If you didn't know, vertices is always h plus a negative a and then k. Always remember that. So basically, if you substitute, it would be plus and negative. Well, a is 5, as we found here before, and then k would be 0 because, well, there's no center. Remember that h and k is center, so that means there's no center at all. That means 0. The foci we found, or we can try simplifying. Now the foci formula is h over k plus n negative c. If you didn't know that, so if you try substituting all that stuff in the formula here for the foci part, well, h is 0, so the center, h is basically involved in the center, so it's 0, and then we have plus and negative c, and we found 3 as c. So we're gonna find c is there, and now, so we found the center. Okay, we found the center, we found the vertices, we found, okay, well, the foci is actually extra, but you could, actually, I forgot to involve foci, hold on. Foci and, yes, I'm just sorry about that. I forgot to include foci, but foci, and now the eccentricity. So the eccentricity formula is actually, so E equals to C over A, and as you think about here, it's 3 fifths, because 3 is C, as where did we? So C is 3, A is 5, so it'd be 3 over 5ths, and this is what you basically fine. So let's make sure if you found everything, because I was a little kind of mysterious last time. So center, we found center. Okay, let's cross that out. Vertices, yup. Foci, yes. And eccentricity, yes. So these are the characteristics of from the standard form of the equation of the ellipse.